Hello everyone, myself Kshitij. Today we will talk about intrusion detection system using SNOT 3. This is my major project on cybersecurity, which is powered by Pregrad. So let us start. Cybersecurity needs an active network defense. So to protect digital assets, monitoring network behavior and detect intrusion early using SNOT 3. The problem core in invisible attacks are growing threats, unauthorized access, monitoring blind spots, and detection needs. So let us start our project. So the focus of on detection will be on by installing SNOT 3 and configure monitor network traffic, improve network security awareness, detect suspicious activities, generate real time alerts using SNOT 3 IDS. So let us start. IDS identify suspicious activities, network based IDS and host based IDS. There are two types. So, in intrusion detection system monitor system networks traffic and malicious, suspicious, and or policy violating activities and generate security alerts and reviews. So let us understand SNOT 3 uses layouts. So it will start with SNOT network traffic, then packet capture, packet detector, decoder, preproposers, detection engine, alert generation, and logs and reports. So the tools we will need for the practical will be Kali Linux, Snort 3, Nmap, Linux terminal, and ETH0 interface or Metaexploitable 2. So let us start with verifying and installing the Snort 3. To install Snort 3, the following steps are on your screen. So Snort V, we will be checking whether your Snort 3 has been verified or installed conf- uh, successfully. So to configure it, snort.lua will be configure your snort by creating a local rules by adding custom ICMP and TCP rules and represent the project specific detection requirements. To validate the configuration, run sudo snort c etc slash etc slash snort.lua slash t to detect the syntax or loading error before monitoring the traffic. So let us start now. As you see on your screen that after adding the code after adding the code, the loading will be start with snort by giving a version of a snort which you have been installed. So my snort installation is 3.12.2.0 version. So as you can see on the screen, the next part will be start. After the after the configuring all the Snort 3, the following installation should be there. So you can see on my screen that the code has been run and the specific on the last the on the last but not least the after that the last code which you can see is the snort is successfully validated and configuration with an zero warning. So snort will be installed and configured perfectly. Now on the second terminal of PowerShell, let us start. So on the second terminal, just code ping space 8.8.8.8 which will be seen on your screen, right? So as you can see, after putting that ping.8.8 on the first terminal, your uh, ping will be started. So on my screen you can see that the ping has been detected. So our projects is been successfully done. So to stop it, just press Ctrl C on the both terminals. So your ping has been detected and your packets will be created. By this project, you will understand that. So next, the snort rules has been defined that the traffic should be inspected, what condition should be trigger detection, and what alert message should be generated. On the first screen, you can see that the ping has been detected with SID 01100001. So the purpose was to detect the ICMP ping traffic, which commonly used for a connectivity testing for an early resonance. On the second portal, we can see that the port scan has been detected. So the purpose was to detect TCP sync packets that may indicate the scanning attempt against the network services. On the third screen, we can see the alert TCP has been detected. TCP connected detected. So the purpose was to detect the general TCP activity to provide a monitoring visibility into a connection attempt. So let us go to our final part, which is conclusion. So implement Snort 3 IDS. Snort 3 was installed, configured, and prepared a packet inspection in Kali Linux lab environment. Monitor network traffic. Traffic was observed by through a detected selected network interface to support real-time visibility. Detected ICMP and TCP activity to custom rule identify TCP connection events and sync with a sync based scanning behavior. So generated security alerts output configured the suspicious traffic should be detected, reviewed and administered. The future scope of this project will be SIEM integration, machine learning detection, cloud security monitoring and threat intelligence. So this was my time for this was my major project. Thank you very much.